two-dimensional figures. All right, two-dimensional, that means I can draw it flat on a piece of paper. Right? These are flat, not 3D. And one of our figures of two-dimensional figures we like to call polygons. Okay, that's kind of our general term for it. A polygon is a closed figure formed by a finite number of coplanar segments called sides. Coplanar, they're on the same plane, that just makes it two-dimensional. And if you notice, they're made up of segments, right? They're made up of segments. So first thing, no curves. Polygons cannot have curves. So circles are not polygons, right? Or semicircles. Anything with a curve is not a polygon, okay? Because they're made up of segments. Also, no sides can cross, right? No sides are crossed because it's a closed figure. So for something like this, that is not a polygon, okay? Because I have sides that cross, right? So no crossing sides and no curves for polygons. Got to be made up of segments. Well, there's two types of polygons. There's two types: convex and concave. And I don't know, my quick trick to remember, concave, I think of a side caves in. A side caves in. If you notice, this side kind of caves in a little bit. That's how I can tell convex from concave. So concave, they kind of cave in. Convex, there's no sides are caving in at all. No vertices. And so if you look at both these, they're both all segments, no curves, no cross lines, and it could be convex or concave. Another thing with polygons is we have regular polygons and, well, I guess not regular, or irregular, however you want to call them. Well, the regular polygon, these are almost like perfect polygons, okay? It's first of its convex, that's our first thing, and it's both equilateral and equiangular. Well, let's talk about what those mean. Equilateral, well, equal, so that means something's all the same, right? And equilateral means sides are the same. So all sides are the same length. And equiangular, well, equal angles, right? So same angles. All angles are the same. And they'll denote this by little markers. So for example, if all the sides are the same, it might give them all one little dash. That shows that they're all the same. If one of these would have two dashes, that means this side would be different than the rest of the sides. So this would not be a regular. But all sides are the same and all angles are equal, right? Equiangular. So they would do something like this. That would show that all of these angles are equal to each other. So this would be a regular, well, what would I call this? This would be a regular, remember we named polygons by the number of sides? In this case, I have 1, 2, 3, 4, 5 sides. A regular pentagon. A regular pentagon. And if you can't remember all the names for your sides for the number of angles, page 57 lists all the different names for polygons. Okay, page 57 will have the chart for that, so you can reference that. So first thing first, we're going to get a polygon, and we're going to name it by its number of sides. Okay, and you might have to glance at 57 just to refresh your memory on some of our names. And then we're going to classify it as convex or concave, and regular or irregular. Okay, so let's start with the first part. Name the polygon. Well, I got 1, 2, 3, 4 sides. So if you remember, a four-sided polygon is a quadrilateral. That's our general term for it, right? Quadrilateral. Then obviously it breaks off into like rectangles and trapezoids and things like that. But it's a quadrilateral. Now it asks me, classify as it convex or concave. Well, it doesn't cave in at all, so I know it's convex. And is it regular or irregular? Well, I can already tell all the sides aren't the same because I have different types of dashes, don't I? And I don't even have to look at the angles, but now the angles aren't all the same either, so I know it's irregular. So remember, regular means all sides and all angles are the same. So this is a convex, irregular, quadrilateral. Looking at the second shape, well, better count my sides. I got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. 9 sides, kind of a goofy one. That's the one not a lot of people remember. 9 sides starts with N. It is called a nonagon. A nonagon. And like I said, page 57 will list all those. And then if I look, it caves in, right? This caves in caves in right here. So I know it is concave And I can already tell all sides and all angles are not congruent, so it is irregular. Irregular. So let's go through our three different terms there. Let's look at this example. It says Terry has 19 feet of tape to mark an area in the classroom where students may read. Which of these shapes has a perimeter or circumference that would use most or all of the tape? So I'm looking at perimeter, right? Perimeter is like the distance around. Distance around. So if I think about this, I might just have to find all the perimeters and see which one's going to use the most tape or all the tape. So first one, a square with side lengths of 5 feet. Well, if I know a square, all the sides are the same. So I have 5-foot sides with 4 sides. So that's what, 20 feet? Okay, that's too much of the tape. I don't have enough tape for that. B, circle with a radius of 3 feet. Oh boy, who remembers our perimeter or circumference, right? Circumference, that's perimeter of a circle. If you can't remember all these, you'll find them on page 58, your formulas. Well, circumference, if we remember, is pi times the diameter, or 2 pi r. 2 times pi times the radius. Well, if you remember, 2 times the radius is really just the diameter, isn't it? Because the radius is half the diameter. Okay, so I'm going to use my pi d. That's the one I like to use. Well, if the radius is 3 feet, that means the diameter is twice that, 6 feet. Right, so if I remember a circle, radius is half, diameter is all the way across. So I have 6 feet for diameter, and I apply pi times 6, pi times diameter. I'll have to go ahead and use my calculator here around the nearest decimal, the nearest tenth. And I get 18.85 about. 18.85 feet. That one's going to be pretty close, isn't it? How about this? A right triangle with each leg length of 6 feet. Each leg length was 6 feet. Well, here's a right triangle. Okay. It says the legs, well, legs are right here because this is the hypotenuse, isn't it? That's the hypotenuse, the one across from the right angle. Okay. And if it's a right triangle, so I can apply what theorem? The Pythagorean theorem, right? A squared plus b squared equals c squared. So I can take 6 squared, which is 36, plus 6 squared, which is 36, equals c squared. So 72. And how do I solve for c? Take the square root. So the square root of 72 gives me 8.485. 8.5 about that. Well, in the perimeter, I would have to add all 3. So add 6 plus 6 onto that. Well, it's already over 20, isn't it? 20.48. If I add all 3 of these together. Okay, that's too much. So I already know it's not A, that's too much. It's not C, that's too much. How about this last one? A rectangle with a length of 8 feet and a width of 3 feet. So I come here, rectangle, 8 and 3. Well, those add up to 11. Add another 8 and another 3. That's 22. That's too much. So I know it's B. I know it's B. Okay, so it's just a matter of going through and finding the perimeter of each one. And lastly, it says find the perimeter area of Pentagon ABCDE with the following coordinates. Well, first things first, let's go ahead and graph this. Let's graph this. That might help us. 0, 4. So 2, 4. That's A. And then I got 4, 0. That's B. 3, negative 4. That's C. Negative 3, negative 4. That's D. And negative 3, 1. And that's E. I'm drawing my line here. So this is a vertical line. Horizontal line. Boom. 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 So there's my pentagon. It says find the perimeter. Well, let's find the perimeter first. Well, to find the perimeter, it's a distance around. Some of these I might just be able to tell. If it's a vertical or a horizontal line, I can just look at it and just count it off. So from like D to E, I can tell that it goes up 1, 2, 3, 4, 5, 6. So that's 6. I can tell from D to C it's 1, 2, 3, 4, 5, 6. So I know those 2 side lengths. How am I going to find the rest of the side lengths? Well, remember a couple sections ago, how do we find the distance between 2 points? distance formula, right? So I need to find the distance from A to E. I need to find the distance from A to B. And I need to find the distance from B to C. So I do all those. Well, if remember, it's let me write the distance formula up here again. The square root of x2 minus x1 squared plus y2 minus y1 squared. Remember, difference between your x's squared, difference between your y's squared. Add those two and take the square root. So now from A to E. Well, if I look at A, x is the distance between 0 and negative 3 is 3, and I square that. The distance between 4 and 1 is 3, square that. So I got the square root of 9 plus 9, which is 18. So I might want to make that a decimal, right, if I'm actually going to find the perimeter. So square root of 18 gives me 4.2. We'll just round to the nearest tenth. Now from A to B, I have, well, let's go back up here now. So 0 to 4, the distance of 4, square it. And from 4 to 0, well, another distance of 4, square it. So square root of 16 plus 16, which is 32. And the square root of 32 gives me about 5.7, round to the nearest tenth there. And lastly, we're going from B to C. So from 4 to 3, that's a difference of 1. So 1 squared. And from 0 to negative 4 is a difference of 4. So 4 squared. So that's 1 plus 16. So the square root of 17, which has got to be what? 4 point something here. 4.1-ish. Yep, about 4.1. So now I know all these sides. I know this is 4.1, this is 5.7, and this guy's 4.2. And to find the perimeter, we just add up all 5 sides. So 4.2 plus 5.7 plus 4.1 plus 6 gives me 26. So the perimeter is 20, about 26. What are we in here? It doesn't give us anything, right? So just units is be fine. 26 units for the perimeter. Well, am I done? No, it told me to find the area, didn't it? So I need to find the area. So to find the area, I need to break this pentagon into shapes that I know how to find the area for. And this one's a little more difficult. Okay, I'm going to have to use some multiple shapes. So I'm going to cut this guy in half right here. So here I have a trapezoid. Okay, I can find the area of a trapezoid. Well, this other guy on the right side is not a trapezoid yet because I don't have one set of parallel lines. So I'm going to have to break this up too. Well, I'm going to go with a triangle. Break that up into a triangle and another trapezoid. So I'm going to have 3 different areas I need to find here. So let's take a little bit of work. Let's start with that blue trapezoid first. Well, might have to look over your area formula again. It's kind of like a triangle, like 1/2 base times height, but I have 2 bases, don't I? So 1/2 times the height times the bases put together. That's the only difference. So it's really like a triangle, 1/2 base times height, but I got to add the bases first. Well, if I look at the bases here, I have a base of 6, right? Because it's the lines that are parallel, and then this longer one, which is what? 2 further. So 8. Just count up the sides. So 6 and 8. So I got 1/2 times. I'll come back to the height. So 6 plus 8. And the height of this, well, that's the vertical height right here. That would be 3 would be the height. And I go through the math. Well, 6 plus 8 is 14. Half of 14 is 7. And 3 times 7 is 21. So 21 units squared there. Go into the triangle, a little triangle. Now it's 1/2 base times height. So my base of the triangle is 1, 2, 3, 4. And my height is 1, 2, 3, 4. So I have 1/2 times 4 times 4, the base and the height. And we end up, well, half of 4 is 2. 2 times 4 is 8 units squared. And lastly, my trapezoid. My green trapezoid here. Same thing, use my same formula from up above. So I have 1/2 times the height. Well, the height, let's see, my height is going up and down this time. So 1, 2, 3, 4, height of 4. and my bases added together. Well, I know this base is 4, and this base looks like 1, 2, 3. So 4 plus 3 are my two bases. And half of 4 is 2. And 2 times 7 is 14. And then we go ahead and add up all our areas. So 21 plus 8 is 29. Plus 14 gives us 43 units squared. So if you're given just one shape, you can find just that one area. Here I had to break it up into 3 different shapes, so it just adds a little bit of time to that work. That's all I got. Good luck.